All right, hi everybody. So today we're gonna look at this question. So we have Bubba, mass 150 kilograms. So let's draw him out here. Bubba on a little sled. Boop, boop. Okay, and he's sliding down this hill and hits a straightaway. So Bubba is sliding down a hill. Hill's very snowy with a coefficient of friction of 0.2. When he hits the straightaway, he goes on to ice, coefficient of 0.01. How far does he sled along the straightaway if he starts from rest? So he's way up here. He's starting from rest, so I'll say V initial equals 0. And our end up goal is figuring out delta X, how far it goes. So this is going to be an indication of using our friction force. Okay, so using forces and using motion. So, okay, we've kind of done hill questions like this before. It's just been a little bit. So let's kind of look at it like this. I'm going to break this question up. Okay, I want to break it up to figure out, all right, if he's up here, what is his speed, velocity, acceleration down here? Okay, so that's going to be what we're going to try to find in order to find his distance. So let's start by doing our force stuff. So free body diagram, okay, of Bubba. All right, so we have weight straight down, normal perpendicular. He's going down, so we have friction going up. And that's it for these main ones. And then we have the two auxiliaries of our force perpendicular and force parallel because we're on an incline. And that's it. That's all we have for our forces. So do some summation of forces in the x equals ma. Summation of forces in the y equals ma. I'll do the y right away. It's just going to be force normal is equal to force perpendicular because he's not lifting off, he's sliding down. So here for the x-axis, let's see, I have force parallel minus friction is equal to ma. And he's sliding down towards the right, so the acceleration should be positive. So now it's just a matter of, okay, what is his acceleration? How fast is Bubba sliding down this hill? Okay. So that'd be now one thing I did forget to add into this question. It takes Bubba 1.5 seconds to reach the bottom. Sorry, I did forget this part. That is necessary. Okay. Anyway, so we got to find this acceleration. So we have these two things. So we're going to have to use our force parallel equation, mg sine theta, our force perpendicular equation, mg cosine theta, and our friction equation, mu fn. Okay, so mg sine theta, we have 150 times 9.8 sine of 25. So let me get my calculator real quick. So 150 times 9.8 sine of 25 gives me 621.25 newtons. The reason why I need to find force perpendicular is because that is equal to my force normal, which I need for my friction equation. So let's find that right away. So 150, 9.8 cosine 25. So type that in. Boop. I get 1332.27. So 0.2 times 1332.27 gives me 266.45 newtons. All right. So I have I'll drop this over here. So I have 621.25 minus 266.45 is equal to 150A. Solve for A. So 621.48448 minus, oopsies, 2. I get 2.3 2.37 meters per second squared. Okay, so his acceleration down the ramp is 2.37 meters per second squared. So what I want to do is figure out the velocity at this point. What do I want to find the velocity at this point? So then I know how fast he starts his motion across the horizontal. So now it's just a kinematic equation. So I'll say at bottom of hill, I have V initial is 0. I have A is 2.37 meters per second squared. T is equal to 1.5 seconds. V final is my question mark. So using the first kinematic equation, V final equals V initial plus AT. Initial is 0. I have V final is equal to 2.37 times 1.5. So Bubba, as he reaches the bottom of the hill, is going at 3.55 meters per second. Okay? So that part's done. Now, in order to find how far he goes, okay, I'm actually going to create another free body diagram. So this is all for the bottom. So this is all to get to the velocity at the bottom. Now to find delta x, we have this new coefficient of friction. So there's going to be, I'm going to draw a second free body diagram. So I'll say across, oh, can you see this? I'm going to say across the ice free body diagram. Okay, so across the ice free body diagram, on a flat surface, weight, force normal, and friction. That's all I have. Okay, friction slowing them down. So summation of forces in the x equals ma. Summation of forces in the y equals ma. Force normal is equal to weight. Negative friction is equal to ma. Okay. So friction, we have our equation from up here still. It's our mu times force normal. So friction is equal to mu times force normal. In this case, force normal is equal to weight. So I have 0.01 times 150 times 9.8. 0.001 times 150 times 9.8 gives me 14.7. 7. That's my friction values, 14.7 newtons. It is negative, so I bring this down. I have negative 14.7 is equal to 150A. Acceleration is negative 0.098 meters per second squared. So he's going at a very, very slow rate as he's slowing down. Very, very small acceleration, negative 0.09. Makes sense because it's a very, very slow coefficient. Okay, ice. If you're on ice, you're going to slide for a good distance. Okay, so have this. This final velocity here is now my initial velocity. So V initial is 3.55. A is equal to negative 0.098 meters per second squared. V final is 0 because he's coming to a rest. And delta x is my question mark. So we're going to use the third kinematic equation. So V final squared equals V initial squared plus 2A delta x. 0 is equal to 3.55 squared plus 2 times negative 0.098 times delta x. So 3.55 squared divided by 2 times 0.098. Delta x is equal to 64.3 meters. Bada bing, bada boom. All right, that's all, kiddos.